To train my AI, I've been using a model called Deep Q Neural Network, aka DQN, and the reason is that my action space is indiscrete, meaning, for instance, whenever AI chooses action walk, the changes in distance are always the same because I multiply by fixed walk speed by fixed delta time, and same goes for direction, fixed rotation speed by multiplied by fixed delta time. So, and these are called discrete action space, unlike continuous action space where distance may varies on different steps. And it seems like that DQN models are suited for this kind of discrete action space, and that's the reason I've been using DQNs. However, I've always wanted to improve and stabilize my AI, and I already, I always knew that there are other versions of DQN that are better, could and also could um, stabilize and improve my AI. So if we search for vari- variations of DQN, there are a bunch of them, and this time I've decided to upgrade to Double DQN. So I was using most standard vanilla DQN, but this time I went for double DQN. And you might think I may need to implement lots of new stuff to achieve that. However, the only code difference is these. So I've only added 3 lines of code, and I also added this argmax function. So implementation wise, it wasn't that hard. So it's nice. So how they differ fundamentally. The so how you so the only difference is how you compute the targets. So before computing targets, you'd have to do uh, extra work on DDQN. And so, first of all, why do I need to compute targets? So, unlike classical ML tasks such as image classification for dogs and cats, uh, with this task, you would prepare dogs and cats images as a data set, and you would use part of them or 10% of them as a target. But I don't know if it's common or standard, but in reinforcement learning and my DQN models, I don't have the data sets, so I don't have targets either. So instead, I need to generate by myself using neural network, and this is where that's happening. I use neural network to generate targets, and I use that to compute the loss. So I need targets, and I do that using neural network. And how they generated are different in DQN and DDQN. So how exactly they differ? So in short, um, in DQN, you select action and evaluate using same target network or neural network. And this is pretty abstract, so I think it's easier to just first explain how DDQN works. So first, so before that, I also need to explain that in DQN or DDQNs, I have two neural networks. So one is the aforementioned neural network that generate dataset, the dataset generator neural network called target network. Another one is called online Q network, which is like a core of a neural network, because on this neural network I only compute the backward propagation where weights and biases gets updated. So I have two neural networks, and I use this Q network to first select best actions for the next step, which could maximize the reward the AI can gain. So I do that using Q neural networks, a Q network, and the next best actions are selected, and I use that to evaluate the Q values. So first I compute the target Q values using target network, and which would look like this. And within these Q values, I need to choose the maximum Q values, but using this next actions. This would be some kind of values or index from 0 to 3, because I only have 4 actions, so the indexes will be 0 to 3. So this, yeah, this contains just, this will just contain some values ranges from 0 to 3. So in this line, I just choose the value, some value assigned to this next actions. So maybe for the first low, it would be 0, so I choose 0.4. So this Q neural network thinks if the AI chooses the idle for the next step, he may gain more reward. And for the next low, maybe in next actions would be index 1, and this would goes on for number batch size. So what I'm trying to say is that target network generates some Q values, and to choose the best Q values or evaluate Q values in DDQN, it would use actions selected by Q network. And finally, this maximum Q values would be used here to compute the targets, which would be used to compute loss and backward. So this is how DDQN works. But if we look at DQN code, it's got only 3 lines, much simpler, and it also computes maximum Q values like this, but it uses only, so it still uses target Q values, but it doesn't use actions selected by Q network. So with DQN, they don't use Q network to choose best actions for next step. So yeah, he would just, and I just said the target Q values would look like this, and with this maximum function, it would choose the highest values within the row. So, but he already decided or generated the highest, the Q values, so he kind of like selected action by himself, and then he just, I mean, and it would just choose the maximum values, and this is kind of like and evaluation. So what I mean by is that within these two lines, they with these two lines of code, he both selected action which would be actions which would be most suited or preferred for next steps, and also evaluation. So, and maybe a good analogy for this is that in DQN you take a test and you evaluate by yourself, but with DDQN another person evaluate your test, which reduces biases or overestimation or overconfident, because this and another person would be this Q network. So yeah, essentially it would again reduces the bias, and mathematically this is the difference. And so for the DQN, the action is selected by this target network. This Q, this is equivalent to this lines of code, and you take the maximum. But for the DDQN, first you compute the Q values using Q network, and you pass that to org max. And so this is like the next actions, and you pass that to here. So, yeah, this would be like these two lines. So anyways, yeah, and what was the outcome? And I would say I think it has improved my AI after I upgraded to DDQN. Before the upgrade, the AI used to jitter and oscillates more often, and it was just behaving weirdly. It wasn't really smart, and yeah, it's still the AI still jitters and oscillates, and it's not perfect, but I can evaluate using moving average and loss, but just by looking at him, yeah, I think after the upgrade, the thing has improved. Yeah, so yeah, the so this video was about I upgraded to DDQN and how it works, and I hope I explained it as simple as possible. So yeah, thanks.